Right, good evening everyone who's watching. Welcome to tonight's Facebook Live, all about balancing. We're joined by our 3 super regulars, and I will let them introduce themselves in a minute. Once we've done the overview of what we're going to see tonight, we're just going to be talking about balancing generally, low flow temperatures and auto balancing and how it's much quicker, easier, better. So I will let Richard kick off with who he is.
Hi, if everyone can hear me tonight, because Kimbo's decided to whitewash us all. I'm I'm Richard Burrows. I'm director from 𝗵𝗲𝗁𝗲𝗀𝗺𝗃𝗍𝗄𝗃 Heating Supplies, and some of the recent stuff I've done is the testing at Salford Energy House with the Drayton Balancing Key TRVs. Over to Rob.
Yeah, hi, I'm Rob Berridge, one of the directors of Heat Engineer. I think, well, I don't know if that speaks for yourself. We're a software company that just do heat loss calculations for buildings, and we also teach this heat loss calculations and some introduction into system design.
Thanks, Rob. And Kim, can we hear you?
Yeah, hey, so I'm Kimbo from the Heating Academy, currently on holiday in Hawaii. If I get a moment, I'll show you my boat, which is just the other side of the road. There you go. So you know I'm not kidding. The signal's quite poor, so I think I'll switch the video off and just listen and try and do my bit that way. Thanks, Claire.
Thanks, Kim. Thanks so much for joining us. So let's start with a bit of a recap. We did talk about balancing back along in the early part of the year, but for new members or people who might not have seen that video, shall we go over it again and talk about what it is, why it's important, and the benefits of it?
Yeah, cool.
I don't know who wants to start on that one.
So obviously, well, I don't know. Do you want to go, Rob? I always start. I'll let you go first.
Oh, right, okay. What we talking about the importance of balancing, the recap of what we talked about last time.
Yeah, so just why it's important and why it should be like best practice on all systems, really.
But if you're over supplying heat to any kind of emitter, you're over supplying heat to any section of your heating system, you're going to get varying different temperatures throughout the property, and it's not going to heat up at the same kind of time. You want to try and get that heat, the right place, right time, right amount, etc., etc. If you don't do that, you're just not, you're just missing out on the whole system balancing and the importance of sorting out and balancing your boiler or your heat source, making sure that heat source is understanding where it needs to modulate and what time.
Okay, cool. Richard, anything to add to that?
So obviously, like Rob's just said, just the oversupply of energy to the radiators, which obviously narrows your delta T. So if your boiler's designed for delta T 20 and we're actually only supplying the system at a much higher flow rate, so we're getting DT5, your boiler can't put the correct amount of energy into that heating circuit. It's not gonna be able to put in the energy because we're not actually stripping out that delta T20 at the radiator end. So it's really important that if we got an appliance that relies on a delta T of like 20 degrees, that we're stripping delta T20 out of the radiator circuit. Otherwise, we're going to come into some issues where actually the design that you've actually done as well on that, if you have designed it, which we should be designing our heating circuits, if we've designed that radiator for a delta T20, so it's a 70/50 or a 55, 35 or whatever it is, if we've designed that for that kind of thing, and then we've not got that temperature drop, you're not getting the correct heat output on that radiator. So really, really key. We've got to balance our systems. And
it's part of the benchmark too, isn't it?
It is, but how many people have actually been doing that for a long time? And the problem with the problem is that it's not the installer's fault. As we kind of in the recent testing at Salford, one of the big things that came from the Salford testing was that if we've got a boiler which has got a high pump duty, and you can't reduce that duty, so if it's like comes out the box and that pumps 80% and you can't take it any lower than that, then you've got a real problem with static balancing, because you're going to really struggle on a small radiator system to get that statically balanced correctly. And a lot of guys just don't bother, just because it's so hard to do that. And that's the beauty of the the pressure independent TRVs, which are the auto balancing Drayton TRVs. So they make a massive difference, and that was the key reason we use them on the Salford University testing, because we had that situation and we wanted to see what measure we could put in place to mitigate the issue of something that had a really high pump pressure. So and they worked flawlessly, which was brilliant.
Great.
They also won't allow any over pumping. Once you set the max flow rate that you want to that radiator or that circuit, once you set that, if all the others shut down, the pump won't be able to pump further into that emitter. So that's kind of your big plus about these.
Mm.
Yeah.
Kim, do you want to chip in, Kim, at all, or are you?
He's just listening tonight. He's just here to listen.
That's okay. So okay, so there's the fundamentals of balancing.
We'll give it a whirl. So my angle is if we know the heat loss of the room at design temperature, and we know what flow rate to put in, if we can calculate the flow rate, why do we need TRVs and room stats? And if you can understand that as a concept, and understand that if we put the right amount of energy in at the right time, at the right place, everything will reach the right temperature and we won't have any waste at all. Now, I've no idea if you can hear me. Perhaps you can give me a thumbs up if you can.
There's the lag.
A few minutes. Yes, there's the lag. We can hear you, Tim.
Okay, I'm on about a 10-second time delay, I think. I'll just perhaps listen, maybe.
He was saying all the right stuff as well then.
Yeah, he was. You're all right, Kim. You just got a bit of a lag in the responding part of it. But anyway. So, Richard, you talked about the Salford House research that you've been part of.
Yeah.
Do you want to tell us a little bit more about that and the Nesta campaign that you talked about yesterday? I know that you did a session yesterday with Installer Mag, didn't you?
We did. So we did so Nesta just launched the boiler money saving campaign. And that's all about lowering the flow temperatures. But Nesta didn't want to just go out there and tell everyone to lower flow temperatures to whatever they could get them, 60 degrees or 55. They actually wanted to put some research behind it to actually have some test data and to make sure that the advice that they were giving was actually worthwhile advice and not going to lead to any issues or problems. So what they funded was research at the Salford Energy House, which I oversaw the heating side and the setup of that testing. And basically, what they wanted to show is that reducing the flow temperature would actually save householders energy and money, and we kind of know it does. Yeah, so most heating engineers know if it's a condensing boiler, most of them don't condense. So we've got non-condensing condensing boilers, as Kimbo always says. Right, and it's an epidemic everywhere we go. These things are out there and at 80 degrees Celsius. So what Nesta wanted to do was do the research behind it to see what the effect of having it from 80 to 60, 70 to 60, and the effects on the system. So they basically did that research. It's all available on the Nesta website. So if you just Google search Nesta, one of the things on their website, you'll see the boiler money saving campaign that they're doing. And you can read all about it. All the Salford test data's there. All the research bit that we did, how it was all conducted. So I'm not going to go into it in every detail, but the fundamental things were that actually reducing the flow temperature from 80 to 60 had quite a significant saving, which was about 12% on your gas usage, which is phenomenal, really. So anyone out there that's running at 80 degrees Celsius, if you actually reduce your flow temperature from 80 to 60, and basically they were saying that for combi boilers, because obviously we've got to be careful with system boilers. You know, we know there are methods and means to actually get system boilers to have two flow temperatures and have, you know, lower flow temperature on space heating, high temperature recovery for domestic hot water. But ultimately, you know, the advice initially is just for apparently there's 9 million combi gas, so 9 million gas combi boilers out in the field. So Nesta's aim is to try and get all those combi boilers on reduced flow temperatures and actually try and save the country all this money. Because ultimately, if we save the country all this money, one key aspect about that is not just the individual homeowner savings, it's actually the fact if we reduce the amount of gas that has to be imported into the UK, we actually save the government and our own taxes from actually funding this gas purchasing that we're going to have to do. So it's in all our interest to actually try and get this advice out there and get it work. So some of the key things about the sulfur testing was that we didn't mimic a new boiler. We had to mimic sort of the most popular boiler out there, which we kind of went for a Worcester-Bosch boiler of sort of the 2015 era. So we actually mimicked like a Worcester Junior, an I Junior. And so that was a 7 kilowatt minimum modulation ratio on it. It wasn't a range rateable boiler. So it was 24 kilowatts at the upper end. Didn't have any anticycle. So it did have a natural anticycle. I think it was about a 2-minute thing. So I did a bit of research on it. But what we set it all up, took all the smart stuff off the boiler, because obviously Salford's test boiler is actually an Intergas exclusive. So that's actually what they use as a test boiler there. And the main reason they do that is because it's very adjustable, and you can adjust loads of settings and make it mimic different things and different boilers, different tests they want to do on gas usage, things like that. It can do all that. So it's a brilliant boiler as a test boiler. So basically we mimic this Worcester-Bosch boiler. We run the tests because I knew we were going to have issues, because the Salford test house only has 6 radiators. So when we were mimicking the pump pressure of the I Junior, basically it was a 3-speed pump. So and the pump was fixed at speed 3. So we were mimicking with the Intergas boiler a 6-meter head pump on a 6 rad system. Yeah. So we had no hope in hell of static balancing this thing. So we were like, right, if we've got this situation, how would we do it? So we were like, well, we got the new Drayton valves come out. Let's install them. Because they'll be able to handle the situation. So what we did, we installed the Drayton Auto TRVs. I set them up as per the app that's on Drayton's website. So we measured the radiators. we did the flow temperature the pressure drop across the system. The temperature drop across the system. And then it gives you basically the setting that you've got to put the TRV on. Excuse me. So we, sorry, I've been really ill the last couple of days, so I'm amazed. I'm amazed on this well.
Well done, thank you.
So we set the TRVs up at the correct flow rates for each radiator, and then we did the tests. And then like I said, out of the test data. Excuse me. Basically, out of the test data, we tested at 80 degrees, 70 degrees, 60 degrees, 55 degrees. 50 degrees, we did 55 degrees with a setback, and we did then, so all those tests were done at 4.5 degrees Celsius, which is the average winter conditions. And then, excuse me. And then we did the what they call the shoulder season test, which is testing then sort of, I can't remember what it was it 8.5 degrees or 9 degrees? I think we tested it for a spring temperature. And those temperatures were done at 55 degrees and 70 degrees. And then the test results were collated. And what it showed is that during the winter, the best temperature to actually set it to both give you the best savings versus not affecting your internal comfort, was 60 degrees Celsius. And in the springtime, when the heat loss is less, you could actually get the flow temperature right the way down sort of 50 degrees Celsius, and you could add extra savings, and you wouldn't actually affect comfort whatsoever. So it was some really good data that come out of it, and other things it did show was the importance of boiler modulation and weather compensation. Because if you actually have a flow temperature that's compensated right the way down to like 50 degrees Celsius, what actually happens is the boiler, when it's got not a very good modulation ratio, is that it cycles the boiler a hell of a lot. And that cycling actually makes the boiler no more efficient the lower we go in flow temperature past 55 degrees Celsius in winter conditions. So unless you've got a boiler that can modulate down further and maintain that boiler running during that period, as soon as it starts cycling, it eats all the efficiency that you can get from condensing. So yeah, the 60, like I said, 60 degrees came the best, and that was for a system that was designed at 70/50. Okay, so obviously, if you design your systems for 55, 45, whatever you design them to, and you get the correct sized heat emitters and the right sized appliance that can modulate, it will work all that much better. So yeah, that was the nutshell of it, basically.
Didn't I see figures running around about saving about 120 quid a year? I'm sure I
I
saw.
think it might be on their website.
Yeah, but was that
112?
£112 a year? So £112 a year. Was that £112 a year established at the old gas prices and the old scenarios? Because it's moving so fast now. What kind of pence per kilowatt hour was it at that sort of saving? Because if
yeah, I don't know, Rob. I'm not.
All I'm saying is that with what's going on now, that's going to be vastly more, isn't it?
Yeah, it's only going to get higher, isn't it?
Yeah, it was a 12% saving. So on gas usage. So if you were £1,000 a year on your gas, you know what I mean. It's a 12% saving. So yeah.
I know when I balance my own. When I balance my own system, I took nearly 6,000 kilowatt hours, just over 6,000 kilowatt hours off a year, which was huge. I mean, it's more like 27, 28% on my own, which but then I've messed around with it and played around with it for God knows how long, which I'm sure all of us three have.
I mean, the test data showed actually, if you can get your flow temperature down to 50. We're all good tonight, aren't we? If you get it down to 50, Rob's the only one that's surviving. So if you get it down to 50 degrees, you can get a 23% saving on your gas usage. But the problem is, in the winter temperatures, we started to then affect comfort. So the actual property wasn't actually getting up to the set point, but it was a 21 degree set point. I've got to get this out there that was a 21 degree set point. Anyone that would have been comfortable with a 20 degrees or 19.5 degree set point, you'd have saved 23%.
What's quite interesting is that I've set my flow temperature now, because I've got an intergas as well, but I've set my flow temperature at 45 degrees as a max out, and I've set my pump speed to match the 𝗫𝗀 that I want to achieve on the system. And last year I did the measurements of what I was trying to get out of each radiator. And basically, I've got one radiator that I need to change. So I need to change this radiator, and then just from I think it's a P+ I've got, and it's a K2 that will be going back in.
Yeah.
And that's it. Then everything is I can run the whole lot, but obviously now I'll have to reset the auto balancing valve, so the auto TRVs, auto balancing TRVs. In order to match the new flow rate for the new radiator that's going in. So it's just going to increase my pump speed a little bit. But to get that down to 45 on a Victorian mid terrace that I've got, that it's 9-inch solid walls, I think is all right. And they're not, it's not K3 rads or anything like that. And we've also got to remember that these AFC technology TRV valves, I mean, just the standard domestic one. I mean, you're talking about 150 litres an hour these things to take through. It's an awful lot of flow, isn't it?
It's a lot of flow. And the just got to reiterate that the Salford test house, again, it's a 1900 house. It's an end terrace 1900 solid brick wall house, and it's amazing really, because you when you actually think about it, I remember years ago, if I'd walked in a property like that before I started doing heat loss calcs and guessing, you know what I mean? There's no way I'd have guessed a 6 kilowatt heat loss on that property, but
exactly.
But that's what it is. It's a 6 kilowatt heat loss.
Yeah.
So, and it's got a 24 kilowatt boiler in it, because that's the smallest combi that is out there. And
that's an end terrace.
Terrace.
Mine's a mid, and mine's like 4.7 kilowatts at -2. So it's really it's a lot less than we think, isn't it? All the time.
Yeah. It's surprising actually, because when you actually see the test data and you see the beauty there is you can carry on testing the same test. It's not like a normal house where every single day the air temperature's outside different, or the humidity's different, or something's different, and there's a variable in there. The beauty is with a Salford test house is that you can literally do the test the one day, the next test is the next day, the next test, the next test, and they're all around the same, you know what I mean? Same air temperature, the same humidity, the same controlled environment. It's amazing because, you know, you can do things in there that you'd never be able to do out in the field. And yeah, you know, seeing that difference that it can make as well, just over those few days that were tested, it's amazing. It's amazing, really. But
it's quite important, I think, to add that, you know, the wider apart your DT is, the less output you're going to get from these programs. So it's really important to once you're trying to lower your flow temperature. If you're lowering your flow temperature, you're generally going to have to increase your flow rate in order to get the same things out, because otherwise we've got problems with existing radiators. Nobody wants to go and buy radiators, and I, for one, I mean, I'm really not a big fan of these K3 radiators. I think they look ugly myself, but you know, it's whatever your bag is. But I think most houses can actually get it done just by swapping, you know, singles over to doubles. But again, this is where the AFC valves come in really important, is that you can accurately get the right heat at the right place at the right time, as Uncle Kim says.
Yeah, I mean, the key thing is, if you're out there, if you're fitting Ideal Logics, or you're fitting 𝗵𝗲𝗁𝗍, or you're fitting boilers that cannot have their pumps adjusted, you need to be fitting the auto balancing TRVs. They're just, you cannot do it any other way. Static balancing will not do it. You will not be able to achieve your delta T's. And even if you do, the second one TRV closes off, it takes all the rest out. So, and that's the beauty with the auto balancing technology as well, is that if you've oversized the radiator, or you've got an external heat gain in that room or whatever, and the TRV does close and shut that off, it doesn't unbalance all the other radiators that are on the circuit, which is what you would get with static balancing. That, you know, because you generally balance with everything open and you test it that way, but you don't account for when your one TRV shuts off here or one there because the rads are too big. Or, like Kim said, in the perfect world, if you've sized the rads correctly and you've got the correct flow, you don't generally need a TRV on it, because the TRV is an air trimmer at the end of the day. And normally air trimmers, just because you've oversized your radiators or you've got external gains coming in. So I do find TRVs handy, especially on weather comp systems, just to trim that air temperature on solar gain areas, things like that. Because if you don't have them, then you will overshoot those rooms and you will put energy into that room that's not required. You know, so you have got to watch that, because one thing I do notice online, people don't really talk about the solar gains you get into rooms, and that is one thing that TRVs will do, because a lot of people say online, and I've seen it on the videos and stuff, is that when this one TRV here shuts off, it takes the energy from the other rooms. But that's not the case. If you've got solar gain into that room, you've got the energy going in that room, and the others that are on the circuit, they can maintain their same flow rates and flow temperatures. They don't need to have to change anything, because you've got that energy gain from elsewhere. And that's where your TRVs come in handy. Also, the other thing I noticed, which the Salford test data showed, is that we had actually set the Drayton TRVs to 18 degrees Celsius, which was setting number 3 on the TRVs. Okay, they didn't touch. So what happened is when the boiler was operating, they didn't actually kick in, because the radiators were correctly sized for the output of the rooms, and because we had the correct flow temperature, which we had reduced to 60 degrees Celsius, which was capable of doing that at 4.5 degrees external air temperature, because the system had been designed for 3 degrees Celsius. Okay, so what we'd done by lowering to 60 is match that the correct energy to the rooms. The TRVs didn't actually kick in at all. The rooms were 18 degrees, but the TRVs didn't shut off. Because I did notice online the other day, someone said about setting the TRVs higher. Like, if it needs 3, set it to 4. I don't think you need to. I think you can just set it to 3. And if the radiators are set the right size, and you've got weather comp or load comp, they won't actually kick in at all. Your TRVs, even set at the correct value. So it was some interesting data for us, but yeah, it's just some key things that I think people are a bit misconceptions out there, because you've got to watch this robbing from other rooms, robbing from energy in other rooms if you turn a radiator off. Well, that's not the case. If you've got solar gains or other heat gains in that room, you're actually not robbing any energy. And by actually not having that TRV, you're actually wasting energy into that room when it's not required. So just got to be careful of that.
Yeah, I get it. I mean, I think there's another point here as well, is that once you've actually set, he's like, so wait, I mean, look, everybody's got to do a heat loss calculation. I mean, if there's no point in having any of these conversations if you haven't started with at least some kind of, datum point. So get your heat loss, get your room by room heat loss done, very easily done. And once that's done, and you've actually sized your radiators correctly, even if you make these kind of engineering decisions, if you like, about whether you're going to keep the existing rads or whether you're going to upsize your radiators, you can look at this. The other point of just extending the flow pipe of the radiator that you've got on bottom opposite end, and you're extending it up to the top of the rad, you're going to get 9 or 10% more output out of that radiator. So that's something to consider when you're doing this. Plus the fact the TRV air sensor is going to work much better because it's more actually. BRE. I've met with the BRE guys a couple of weeks ago, and they were saying that no, actually there's more comfort when it's actually at a lower level than it is at a TBOE. Now I don't know what that data is, but that would be interesting to see that data. I haven't seen it, but I'd like to see the data. So if anyone listening has got any heads up on that, that would be a great bit of information to have.
Yeah, I don't know if they calibrate them for bottom opposite end though. If I don't know, maybe Claire knows that. I don't know. Do you know if the tech guys do? We'll have to get them on one evening.
We need to know.
Interrogate them. We get the Drayton crew on and interrogate them to death.
Interrogate them live on Facebook. That sounds like a good idea. Ross and David love that. No, I don't know the answer, Richard, I'm afraid, but I can find out if you tell me what you're talking about.
Yeah, well, just the TRV position. So where your liquid expansion head is. Yeah. So we have them at the bottom of the radiators. What I was asking is it calibrated for the bottom position? So if then you move it up to the top of the radiator position.
I haven't actually got a box here, but I think there are some directions on the box of what not to do. Like there's the bottom, obviously standard for the UK homes is okay. But there are some, I think, horizontal at the top is a no-no. I think that's the European way of putting TRVs on. But I think most of them, it is on the box.
I think it was vertical on the top.
On the top,
was it? I think it was vertical, wasn't it? I don't think it was horizontal. I think it was vertical.
Vertical at the top of the rad is a no-no.
Yeah.
Really?
Yeah.
Well,
Well, it is sticking. If you think it is sticking over the top of the radiator, then isn't it? Do you know what I mean?
Yeah, I guess so. Yeah, if it was horizontal, it'd be better. I mean, horizontal's better anyway, isn't it? Because it's out. It's out of that direct radiated heat from the valve to a certain degree, or better. But I mean, I don't know how accurate you want to get with these things. I mean, once mine are set, they just get left alone. And I think now, like with with liquid heads as we've got now, they're all very, very responsive within sort of 20 minutes or so for 1 degree, which is pretty good. But I mean, look, I would say that it should always be TBOE if you want to get the most amount of output out of the radiators. That was my point. Yeah. And then obviously the flows are a completely different thing.
Yeah, I think that this is, I don't know how well you could see this, but this is what's on the box.
Can't see it.
Hang on.
I got it. Yeah. Yeah, it's sticking over the top of the rad, isn't it, that one?
Yeah. So it's going to get,
This is on the box for the TRVs. So everyone will see this when they buy them. And it looks like that's the only one that's not permitted.
Yeah, so horizontally at the top is fine. So they've got the inline valves there with horizontal is absolutely fine. But
that makes sense.
You've got to remember your flow direction as well, though, with the because obviously they're unidirectional, the auto balancing TRV. So if you were putting them on the top, you would have to have them horizontally off the return, if you know what I mean. You'd have to have them on the return pipe. So you wouldn't have them at the top. You'd have to have them at the bottom horizontally. So because you'd have top with your flow in, and then you go through your radiator to the return, and you'd have to have them horizontally on the return if you were gonna fit top bottom opposite end.
Okay, so there's a question that Rob, I think you might want to jump in on. Stephen Hurrell, has just asked, how do you do a heat loss calculation?
Good question.
I know that's not the topic of this conversation, but I think we can expand.
Well, we could do it quite quickly. Stephen, did you say?
Yep.
Yeah. Hi, Stephen. Basically, as long as you're following a protocol which is EN12831, there's lots and lots of companies out there doing heat loss calculations. Obviously, we do them. We've even got a free estimator tool, but that's just for a whole house calculation. If you go to www.heat-engineer.com, you can have a look. You can also do room by rooms with ours. It's very, very simple. As long as you've got a laser measure or a tape measure and you can use it and you can measure window areas and floor areas, you'll be able to do it. It's not that difficult. One of the hardest things to actually get right, because we're plumbing and heating engineers, we're not building surveyors, is to understand the wall, floor, roofs, windows, and door makeups. Windows and doors are generally fairly easy to recognise and see, but how do you know how thick? You know how thick a wall is, but how do you know what the wall makeup is? And that's something that we teach on the course that I do, just to give you an insight into how that works. And again, with floor structures, how do you know? There's a lot of ways of finding those things out. If you don't know a lot of these things, then your local building controller are always a very, very good resource to get a lot of this information about which building's what. But currently there's only 3 building regulations that were relevant to this. So you have a different types of house. Those done before 2000, those done between 2000 and 2006, and then 2006 onwards. So as long as you know the history of the house, then it's pretty straightforward. You're only going to get sort of 1 or 2 different construction types that make up those. So, but heat loss calcs, EN12831. Make sure that that's followed.
Okay, thanks, Rob. And obviously, Rob does training courses on heat loss calculation. So we can put the link to those in the chat after we've finished. We've put them on the Facebook group before, but we can just do a little reminder.
Sure.
There's a follow-on question from that one as well, from Paul Ashby, who asks similar: what heat loss calculator can you use? I've got a 𝗵𝗲𝗁 200 system boiler with weather comp or new rads, Drayton auto balancing valves and 𝗻𝗲𝗁𝗁𝗄𝗧. And can you confirm that we can use the 𝗻𝗲𝗁𝗁𝗄𝗧 with the auto balancing valves? Yes, Paul, you can.
Well, I think I just said what heat loss calculator. Obviously, I'd like you to use ours. We built it, but to be honest, it's everything that we've built has come from all of you guys. We don't. Our ideas were the initial kind of skeleton, if you like, of the system. But you guys have put all the skin and the muscle and the rest of it onto it. It's now a really good thing, and to be honest, we're flying at the moment. We're struggling to keep up with new users that are coming in, which is fabulous for us. Biggest problem we get now is we've got about 74 brand new tools that we've built. We're now trying to find developers to actually build them for us, which is a thing. But I mean, look, you can always so we'll leave some contact details in the chat if you want to have a private call afterwards, and I'm very happy to do that.
They're just going on though, because he asked about the 𝗵𝗲𝗁 200 series. So one key thing you need to know about the 𝗵𝗲𝗁 200 series is that you need to maintain a meter head of pressure across the valves for them to operate correctly. So the 𝗵𝗲𝗁 200 series pump will actually, I think, modulate lower than that. So you just got to make sure that you cap it. If you can, I'm not sure too much. I'm not a pro on the 200. Our business is just about to start supplying them, so I've got to get into the books and make sure I'm up to scratch on them. But I'm sure the 200 series pump can go below that minimum required pressure, which could cause them to short circuit. So you do need to make sure that the pump pressure on the boiler does not go lower than a meter head of pressure. Otherwise, you're going to come into some issues with the TRVs.
Yeah, that's up to I think 10 rads, isn't it? If you go any more up to about 15 rads, it goes up to about a meter and a half or 2 meters.
Yeah, standard system. Yeah. So you just got to make sure those minimum requirements are made with the auto balancing TRVs. Otherwise, you like I said, you'll come unstuck with it a little bit. So
so everybody knows, when you see it on the valve listing, it'd be 10 kPa.
Yeah,
so 10 kilopascals going across it. But yeah, I mean that is the thing, isn't it? I mean the other thing. I mean, I think with the 𝗵𝗲𝗁s and with some of these other lower modulating boilers, they've still got a bit of this issue with the fact that the pumps that are being used at the moment. I think the most efficient pump at the moment will only modulate down to about 240 litres an hour. And that's just way too much, because what it'll do, if you're going to get as low as a 𝗲𝗲𝗁 would go to, about 1.9 kilowatts, something like that, it squeezes the DT so much in order to get that to work. So, I mean, we've had this conversation many times. I don't think you can get a gas burner to be stable at anything less than about 1.9 kilowatt. I think that I don't think you'll get flame stability with that. But if you're balancing to it, I mean, the whole idea of the balancing is to make the return temperature rise quicker and get that message back to the boiler to modulate down quicker, and that's where a lot of the savings are coming from.
Yeah, you got to bear in mind as well, when we're setting the auto balancing TRVs, we're always setting that flow rate for your worst case scenario. So you have got to bear that in mind as well. So you're always going to have a bit too much flow rate when you actually come to reducing your flow temperature, which isn't a bad thing because we do need a bit more. But obviously, as your temperature outside rises and your actual flow temperature starts dropping off, we saw that on the Salford test. What actually started happening is the DT actually started narrowing the lower the flow temperature we went, which is kind of what happens because your heat emitters now can't give the correct output that they were sized for to the room. So actually your DT starts narrowing because the energy just simply isn't being stripped out of the radiators, and that ends up returning back to the boiler system. And then that's when your boiler then has to start modulating down because it can't get the energy it needs to into the circuit. So it's no longer a 20-20 system where you're putting 20 in, getting 20 out. You now got something that's trying to put 20 in and the rads are only taking 15 or 10 out. And then it's got to drop its kilowatt output down. Otherwise it's going to end up putting too much in. So yeah, that's kind of it in a nutshell. But that's something else to bear in mind with the auto balancing, that when we do that, we're always setting them up for our worst case scenario. So don't ever set them for your best case scenario because then they won't have enough flow rate for your worst case. So that's just something to bear in mind as well.
Okay, cool. And Paul asked about whether they go underneath the 𝗲𝗲𝗁𝗃 head, and they do, don't they? They fit perfectly with because they're the Drayton valve, so they're basically designed for the correct valve. So yeah, Paul, that is the ultimate system really, with the Drayton, where Drayton's concerned. And Rob, Paul's actually local to the factory. I don't know whether you've done any training courses in Plymouth or considered Plymouth for a venue.
We are planning on coming down. I've got what we're trying to do is we're trying to find. And Kim's in on this as well. Kim knows what we're trying to do. We're trying to find probably about sort of 20 or so training centres dotted around the country that we can just, that's it. That's our homes, and that's where we go to each one. We've established now, I think, about 6 or 7 that we're doing. We did the last time we were down. We went a little bit further down than Plymouth. Oh, actually, no, we didn't. No, where did we go?
Newton Abbot.
Newton Abbot. Yes, we did. We went to Newton Abbot. But look, we're always looking for decent venues, and I mean, as long as we can sort of get, sort of like 12 to sort of like 14, 15 people in a classroom, then it makes it viable. We can keep the costs down for everybody.
Yeah. Let's have a conversation, Rob, because we've got training rooms in Plymouth, and we would love to host you and have you bring guys to the factory, and they could do factory tours as well. We could. Let's have a conversation about that separately. But Paul, watch this space. Paul, Rob will put the link in anyway for the training. Sure. But we'll have a conversation about that, and that could be really nice if you used us as one of your
I'd love to, Kate.
One of your venues.
Yeah, love to.
And then Essex as well is being requested as a.
Yeah, well, I'm doing one down in Chelmsford in a couple of weeks' time, but that's sold out, unfortunately. But we can go back there again. That's at Smith's Environmental. So yeah, but I mean, this what do you call it? A podcast? Is it a podcast? Is it me? What is it?
It's just a little live session.
I never know what to call these.
It's a chat session. Yeah.
This is not about heat engineer. This is about balancing. So yeah, I'm happy to speak to anybody that wants to. I mean, my email is just rob@heat-engineer.com. So it's very, very simple.
But the point is that you were making, wasn't it, Rob, that you cannot do any of this that we're talking about without a heat loss calculation. So
everything, if you do, that's all you do. It's finger in the air. You're just guessing, and there's no point. And all you'll be doing is you'll be getting your clamps out, and sticking them on the flow and return, and trying to maintain a delta T from that, and you'll just be there for hours.
Well, you know what? I've been helping a couple of guys out over the last couple of days actually. That have, one guy hasn't been on Kimbo's course or your course yet, and I've pointed him both directions, which I think he's now booked. So, but he was going that he'd been round and added up the rads and kind of watched a couple of Heat Geek videos saying about the footprints, just saying rough approximations of watts per square meter based on the footprint of the property, which is fine for a guess, isn't it? Do you know what I mean? And if you're doing a customer estimate, you don't want to be wasting your time doing a full heat loss calculation and then you don't get the job. Don't bother. Go into the job, have a rough stab at it based on some fundamental principles that people have put out there that are general. Put your price in, and then when the customer accepts, then go back, do a full heat loss calculation, so you can actually then size the boiler right, get your rad size right, everything else in that. But it just gives you a bit of an idea. And yeah, I used to do that myself, to be honest. I didn't used to do full heat loss calculations to start with, but I used to do it the old method. Rob's seen my bloody Excel spreadsheets, which are terrible, really. But they're all based on the 𝗵𝗲𝗄𝗃 design guide, and so they work quite well. But I wouldn't bother sitting down and doing that until actually I got the quote actually accepted, and then you can go back to it, spend the time on it, and make sure then it's right. And ultimately, what you'll end up with is a happy customer, because if they ever got a question, you can just have the printed heat engineer report and go, well, there you go, that's everything I did. There's all your rooms, there, all your heat losses, everything else. That's the boiler I've put in based on that sizing. These are your heat emitters that I've done based on the room by room heat losses. You've got no comeback at all. And, from that point, you can set it all up. The customer's going to be happy because they've got a system that's going to operate correctly and be as efficient as it can be. And there's nothing not to like, the Drayton TRVs, they're just going to game change everything. So if you have a look at the Salford test data and have a look at the actual balancing on the on the radiators themselves, you can see when we set it up for 70/50, the DT20 was nearly bang on. I think it was like 19.8 degrees Celsius delta T across the circuit. So it just shows that how accurate you can get it. And that was with a crap pump. So that was with a boiler pump at maximum. Do you know what I mean? And if that's the other thing you need to think about as well. Because you go out there and you think, right, you put these auto balancing TRVs, and then the pump actually is then whirring away, and you think, well, wouldn't it be nice to reduce the pump speed a bit? I don't need it that fast, and then your logic starts coming in, and you start thinking about it and going, cool, that pump's going way too fast. You could hear it whistling a little bit, the pump on the as you can well imagine, a pump set to speed 3, and then we were balancing that heating circuit. It was down about, I think it was about 500 litres an hour or something like that. Yeah, I think it might have been less than that. And that pump probably would have been capable of sort of 2,000 litres an hour. Yeah, and we've squeezed it to 500 litres an hour without reducing it. And it's a problem that the modern boilers, if you get a good one, you won't have that problem because you'll be able to adjust that pump. But there are still boilers on the market right now, Ideal Logics and 𝗵𝗲𝗄𝗃s, that use pumps with high pressures, and that's a real issue. Then hopefully 𝗵𝗲𝗄𝗃 and Ideal will change that going forwards as we get the lower modulation ratio boilers and stuff like that out there. Fingers crossed they'll come over, because it's making your guys' jobs hard, unfortunately.
Okay, it is. Here's an amazing statistic for you. I couldn't believe this when I heard this, but 10% of all electrical wasted energy in the world is taken up by dead-headed pumps. Now, you just think about that. Let that sink in for a minute. We are talking trillions and trillions of pounds here. Do you know what I mean, in monetary terms? Because they're all dead-headed. You go into any kind of NHS hospital or anything like that, and you look at these things whizzing around. Honestly, it's massively, massively oversized. I mean, I teach this in my course, and I do an index circuit exercise to try and let people understand what it is. But I mean, just quickly going back to the heat loss side. I mean, if you've got one of those, you see what that's just a little Bosch laser measure. Use one of those. I can measure up a 4-bedroom house that and then enter it into our app in about an hour. And then once that's done, I can complete the report in about 20 minutes, 25 minutes at home. So, you know, an hour and a half of your time to do a room by room heat loss calculation and then what I've done with the guys that I specify for and do drawings for is literally I give them the heat loss report. They know exactly what it is. They know exactly what radiators that size, because we've got tools in our software that size all the radiators for you at whatever DT you want to set and whatever flow temp you want. It will tell you exactly what the outputs are, because we do all the correction factors for you. But once you've got that, we give the report then to the installers. And the installers, they go out and buy, you know, 15, 20 TRVs, however big the radio system is, and they sit there either at home or something like that, right on each TRV box, lounge or landing or whatever it is, and just sit there with the report, set the valves up exactly what you want. I mean, these guys came back to me last time. They said it saved us nearly half a day's work. You know, just by doing it all before you even get there. I mean, it's done. You know, you fit the valves, fill the system up, and it all gets up to temperature exactly at the same time. And I tell you what, there's not a better feeling in the world than that, really, if you're an engineer.
Yeah, I mean, you got to bear in mind as well. The other thing I missed earlier that I wanted to say is that Rob touched on it a little bit, but 150 litres an hour, the Drayton auto balancing TRVs can actually get through them. Yeah. Just to put that into perspective, that's about 3.5 kilowatts. Yeah. So at DT20. So, you know, when we're talking about getting, you know, putting TRVs on systems and what their capabilities are, you know, you're not going to get many properties where you're going to get an individual radiator that you need 3.5 kilowatts at DT20. So, you know, these are very capable valves, and you know, and when you go, they can. I know Drayton for some reason say not to use them with heat pumps, but you could use them with heat pumps, because 150 litres an hour at 𝗪𝗪𝗺 is still going to be capable in most houses that have, you know, a 500 watt rad or something like that. Do you know what I mean? And that normally where you put a heat pump, it's going to have a small heat loss anyway. So these valves are going to be capable as well in that environment, as long as you do your calculations correctly and you adjust them to the correct flow rate. You're not going to have any issues with that. You know, fingers crossed. Are Drayton doing a bigger flow rate TRV as well, Claire? Do you know, in the future? Or
I think there's, Dave has mentioned, like you say, with the recommendation or the calculator doesn't go below 55, I don't think.
Yeah, it doesn't.
And I think that you've used them lower than that, haven't you, in these tests?
Yeah.
So he was saying, and that's the reason for them not being, you know, recommended for heat pumps or whatever. But obviously this data shows that that's not the case. So I don't know. He was talking about creating a version that worked with lower flow temperatures. So but you know,
I just didn't want any of the, oh no, this auto light's annoying me. You have to,
so many technical hitches tonight. I think Rob, you're the only one who hasn't.
Oh, it's hilarious though, isn't it? But yeah, because obviously what I don't want people doing is being put off, because obviously with the you know, getting the flow rates right on heat pumps is really critical. So you know, and they've got a lot of volume of water flowing around those heating circuits. So you know, getting that bob on, because like Kimbo said earlier, you know, when they're accurately set up and the radiators are sized correctly and you've got the correct flow going through them, and they're weather compensated, they're always going to be right. You know what I mean? It's always going to be good. It's always going to work. So you know, I don't want people put off using the auto balancing TRVs in that scenario, because they're bang right for that situation. Yeah. Because ultimately, you know, we want people to use these. We want people to fit them to systems and make systems more efficient, because if you're fitting Ideal Logics or 𝗪𝗪𝗺, I keep saying those two boilers, but unfortunately, those are the two boilers out there at the moment that don't have fully modulating pumps. If you're fitting those boilers and you're not fitting them with auto balanced TRVs, you're never going to get those heating systems balanced correctly. It's going to be impossible. So you need to be investing alongside those. I'm not saying don't fit those boilers, or maybe I am, maybe I'm not, I don't know. But, you know, I'm not saying don't fit them, carry on fitting them. But if you are fitting them to people's circuits and you've got 6-7 rads, you need to be fitting auto balanced TRVs, because you're not going to balance those systems correctly otherwise. So
I think something else to add to that as well is that, you know, we're luckily most of the radiators in the UK are sized aesthetically, so they're sized. You know, they're not the postage stamp radiators that you get in the brand new builds and God knows what. They're not like that. You know, you size them to fit nicely under a window and make it look nice, and so they're generally bigger than they need to be. So that's a lucky thing that we've got, and it doesn't matter. You can't oversize a radiator because if you've got automatic flow technology in front of it, you can have a whacking great big radiator, and you can still balance it down to get 200 watts out of it. And that's the whole point about this scenario. And you'll never ever get more than 200 watts out of it. That's what these things will do. So it's a fantastic tool to, what I say when I'm doing my course is that, for the last 40, 50 years, our training, we've been hitting that wall, all right, with our calculations and our guesswork. Basically, we've been hitting that wall when the target is actually on that wall. And all these valves do, and all the courses that Rich does, that Kim does, that I do, and stuff like that, we just get you off that wall and onto that wall, onto the correct wall. Then it's up to you to get better at the job and get closer and closer to the target. And that's what all this is about. It's all just about getting a little bit closer to the target, what we're trying to achieve, and squeezing as much of that efficiency and stuff out of the tools that we got for and just getting new tools like this is a real boon for the industry, in my opinion.
Yeah, I think really, manufacturers getting on board with us. I think because the manufacturers that are fighting against us at the moment, they're not going to win at the end of the day, because we won't recommend their products. We won't recommend them on the courses. We won't recommend their products. And ultimately, once the installers come across, like Rob said, from that wall to this wall, they're not going to be fitting your products. That's what it's going to be. And everyone who sides with the correct way of doing this, and we'll promote the hell out of them. That's how it's going to go. And these are the tools that installers need to do their jobs. And I don't know who comes up with these boilers and who comes up with these ideas of not allowing pump modulation and not allowing them to be set up correctly, or not giving installers the pressure loss graphs across the heat exchangers, and not all the stuff that engineers and installers need to know. They need to know that stuff. You need to put it in your manuals. You need to give the installers the tools that they require to go and do their jobs properly. Because if you're not doing that, you will no longer be recommended by our organisations, and that's the way it's going to go forwards. And as installers get educated, that's the way they're going to go. They're not going to use those products anymore. They're going to use the products that make their jobs easier and keep their customers happy. And while we're in times of energy wastage and this energy crisis we're in, the people who can make their customers save energy and money, they're the installers that are going to win in the longer term, and they're the ones that are going to have the business, because they will have the recommendations to do those works. And like I said, the auto balancing TRVs are, like Rob said, it's a brilliant technology. There's nothing bad about it, as long as you follow the rules and you set them up correctly, and Drayton have tried to make that easy with our online calculator. If you use all that, and it's really easy. I had the Salford Energy House 6 radiators set up in under an hour. So, and that was basically that was me going on the online tool, putting the inputs in, working it out, going back to the house, setting all the flow rates, and then actually getting the heating circuit up and running. And actually, there's a big TV screen in the Salford house, and you can watch all the 𝗫𝗁𝗁𝗃s of all the radiators. And I watched that for about 2 hours, just making sure everything was coming up and everything was right. And it was amazing, and when you don't get to see that, unfortunately, but when you do see that, you understand why this technology is so important and key critical for all the installers out there. So bravo.
Yeah, exactly. I think the cat is truly out of the bag now. It's we certainly Kim, Rich, and I we've been shouting about this now for God as long as I can remember. And we were shouted down and all sorts of things now, but it's more and more engineers are coming on board, getting a little bit of basic training, and the maths really aren't that hard. And these maths have been around. Since Kim was a boy, and that's saying something. Bless him. They've been around for donkeys, and the bottom line is, as we're waking up now to try and understand this technology and this understanding of balancing and getting this right heat around, it's the snowball effect has happened. I mean, literally in the last, I can't tell you, but the last 6 months, it's just gone absolutely wild. You know, it really
Yeah.
has, and this is what you want. So, guys, all you guys listening, get on the courses that we offer. Go and talk to your mates, spread the word, speak to your clients, because if we can win the hearts and minds of the public, especially now with bills as they are, you know, if you can go to your client and say, look, do you know what? I've looked at these Salford tests, and if we put these balancing valves on and we set everything up correctly, that we can save you 12% of your bill, or around 112 quid at those prices then. So probably more like 300 quid now, or maybe 350 quid now. I mean, nobody's going to say no. You know, the wallet is the decider, isn't it?
Absolutely.
Yeah, it's a no-brainer. It really is. I mean, there's nothing out of that test data that was the beauty of the Nesta tests was the Nesta is completely independent. They're not a manufacturer. They're not trying to falsify anything. They're not trying to bias anything. You know, they're a charity for social good. So there was nothing in this to hide. I'm one of those people. Everyone knows me in the industry I don't fudge this stuff. I wouldn't do a test that isn't accurate. I mean, I'm a perfectionist, and everyone knows that about me. And when I do a test or something like this, it's done to perfection. So that's what we were looking for with the 𝗪𝗺 balancing across the space heating circuit, and the Drayton TRVs delivered on that. You know, there's no question about that. Without them, there's no way we would have achieved the 𝗪𝗺s across the heating circuit. Certainly not in an hour. So that's the key thing to remember. We balanced the 6 rad system in under an hour, and that was with the calculations that we had to do. So I'm going to step back from that a little bit. So the radiators were calculated correct size for the room. So I've just got to say that, because the heat loss counts were done and the rads were right size for the room. So when I put the right size rads into the Drayton calculator, it gave the correct flow rates. Okay, so you have got to bear that in mind, because obviously if you go and put the radiator, so put a 3000 by 600 K3 into Drayton's calculator, then, and you haven't calculated that out, it's going to put in that energy into the room that it was designed to do, and not necessarily what you've calculated it to do. So you have got to be careful there. So that's, but as long as you've done that, then you can use the online calculator, and it works brilliantly. So. Or if someone's come along in the past and they've sized the rads and this, that, and the other, and you don't know what the output is, you can use the calculation tool there and actually see if it's roughly where you've calculated it for. Because, you know, the quick math one that Kimbo teaches on his course is basically kilowatts divided by 84 times 3,600, and that gives you a flow rate in liters per hour. So if you know, and that's how I do all my quick maths, and that's for 𝗪𝗺20. So if you're going into a gas boiler system, kilowatts divided by 84 times 3,600 gives you your flow rate in liters per hour to that radiator. And then say that was, I don't know, 100 liters an hour or 90 liters an hour, you'd set that to 9 or 10 on the auto balancing TRV, and away you go, you know, and that's all there is to it. So you can just reinforce that with Drayton's app, that if you went to a radiator and you calculated it out and it come out at 80 liters an hour, and then you actually you calculate the heat loss in the room and you came out about 70 liters an hour, it isn't actually that far out, you know what I mean? So you just tweak it to 70 liters an hour to get the correct output out of it. But you know, it's brilliant, you know, and I like to say bravo for Drayton for doing this, because you know, and talking about auto balancing TRVs, because you know, for a long time they've been in the marketplace, but no one's really talked about them. No one's really cared or pushed them as a product. And you know what Drayton's doing by pushing them out there and getting the awareness out there is brilliant, because they will just, you know, they are more expensive, but they're going to cut down your install time, and they're going to keep that system balanced forever. So you can't go wrong, you know.
I've just got one thing to share. Somebody's posted, I think it's Stephen again. Let's check. Yes, Stephen again, who asked a question earlier, and he said he was working in a house as an electrician. The customer was asking about self-balancing TRVs with wiser heads, and when he said that they were 60 quid per radiator plus labor, he said that would cost too much. But realistically, you know, how long is it going to take to make those savings? If we're saying that minimum 12% is what they're going to save, and how much is that off of their bill each year? Okay, it may be a couple of years, you know, repaying, but this is what these guys, this is why we're doing these sessions, so that we can help the guys, give them a reason to to make that justification to their customers. So yeah, you've got to pay for the heat loss calculation, but at the end of the day, it's going to save you X amount of energy and money off your customer's bill. So that's a reason to do it. Same for balancing, same for turning the boiler temperature down. I know that customers can do that themselves, but you know, we're backing this Nesta campaign because we've been talking about it, I know, only since this year, but you know, we're fully behind it and going to be sharing the information. Paul asked earlier about where we can get the data, so I'm going to share a bit more about the Salford testing on the group, and you know, talk about that, and I'll share the link to the money saving boiler challenge and all of that stuff. But you know, it's these bits of snippets and nuggets of information, like how we give these guys the information to get their customers on board with all of this messaging, and how they kind of sell it to them, isn't it? It's how they convince them that actually that initial investment is a bit of a no-brainer.
Yeah, it's more than that though, isn't it? Because obviously, if you've not done a heat loss calculation, you're guessing the boiler size, you're guessing a lot about that property. You know, if you've heat loss calculated it, you might be able to fit a smaller boiler size, which is then cheaper than the one your competition was going to supply and fit, and you're making more money potentially as well. So if you're going in there with similar pricing, but you've put a smaller boiler in, you've done, you know what I mean? It might even balance itself out, to be honest. So what you pay extra on the Drayton TRVs, you know, it's balanced itself out in the cost versus the guy that's not actually changed the TRVs at all, you know, and, you know, but you're going to add that extra benefit and that extra selling benefit to your customers. And that's what it's about. You know, it's not about Drayton selling TRVs or us promoting TRVs and you buying them. It's about actually, you know, getting the systems working right. And, you know, there's only having the most efficiency out of these systems. Otherwise, you know, why are we doing this? What's the point, you know? And
I think that's a really good thing about this Nesta campaign as well, because it is the homeowners at the end of the day who are questioning the installers' quotes and invoices. And if this campaign that Nesta are running is going to just bring that awareness of more efficiency, and how do so now I've turned my boiler flow down, how do I get even more efficiency out of my boiler as a homeowner? And I'll talk to my installer, and then it's going to be the installer's job to then spread the word about all of these other things that need to happen in order to make these systems as efficient as possible. But I think this Nesta campaign is a really good stepping stone to help educate homeowners on the fact that their systems aren't actually probably as efficient as they ought to be. Yeah, and I think it would just then follow on, won't it?
The exciting thing for me, actually, right, is not just the Nesta campaign, but the Nesta campaign at the moment is solely aimed at combi boilers, where at the moment the advice is system boilers coming soon. When the system boilers coming soon arrives, installers are going to have a lot of work off the back of it. That's the exciting thing for me, and what should be the exciting thing for the guys out there that are going to go out and give the homeowners the 2 flow temperature boilers. That's going to be the exciting thing, because what this campaign will do is all the people that want to get involved but have got are going to go, where's my light? So that's the first thing they're going to say is, where's the light? Like this. And then no, I mean, I'm joking, but what they're going to do is they're going to go out there and they're going to say, you know, why can't I do this with my boiler? What is it? And they're going to get their installer come out and they're going to go, well, you've already got an alpha boiler, my love. And then I'll go, oh, all right, what's that mean? Well, it can already do 2 flow temperatures. All I've got to do on this boiler, I've just got to add an NTC sensor to it and put priority valves on your hot water recovery, and off you go, love. You know, you're going to have a 2. All right, I didn't know, because what the guy's done, he's gone out there and fitted it on an S-plan system, you know, and it was a capable boiler. And there's probably going to be about 1 million boilers or more out there that are already going to be capable of 2 flow temperatures as a system boiler, but they're going to need installers to go out there and do that work. So what an exciting time to be in. I can't think of a more exciting time and a more beneficial campaign than the Nesta ones going forwards, because it's going to raise awareness in the heating industry so much, and like I said, bring that emphasis back onto the installers. So, you know, which is brilliant.
Yeah, absolutely. I think if anyone's got anything else, we're going to wrap up because we've been on for a while. It's been a fantastic chat. Rob, go on.
sorry, I just want to add. I just put my email address and the link to all the training events on the Drayton groups up on the Facebook group now.
Fantastic, that's amazing. I was gonna just say we'll get that added. We'll get Kim's training shared as well. You can buy the auto balancing valves from Richard. It's got loads of stock of them, I think. Yep. So Richard's shop. Richard can put the link to that in as well. I'm going to share a bit more information and the link to the Salford data and the Nesta campaign. So loads of sharing. I'm also going to try and get a section on our website that's all about this sort of education and all of this different aspects of it. I think that's going to be we've got an energy efficiency page, but I think that, having all of this stuff, specifics about the heat loss calculation, specifics about balancing, specifics about everything we've basically covered in the last 9 months or whatever it's been, and get that up and running. So, and also, Steve, I know you've said, how would you convince the customer? I hope Paul's comment back to you on that one has helped. But, we'll add some tips on how you sell this information in. Like that 12% saving is a really key piece of information to share with your customers, but we'll try and see what we can do to help with that sort of thing as well, and how do you justify this extra cost and that extra cost. Just
a quick point, Claire. I just want to make a quick point on that very quickly. It was 12% saving from 80 to 60. If you're designing your heating systems for 50 degree flow temperature, okay, it was 23% savings. That's wow. That's the difference. So between that guy out there that was doing 80 degrees, if you go in and you design it for 50, you'll save that homeowner 23% on their energy bills.
50 was it, Richard?
Yeah, 80 to 50 was a 23% saving.
Okay, cool. That's a killer. That's nearly a quarter of your bill.
Yeah.
That's nearly a quarter. That would be incredible, wouldn't it, if we could all do that? So just to sign off, I'll put all of those links in the chat. Thank you guys so much for joining. Kim, thank you so much for getting off your cruise ship and sitting outside that cafe with your coffee and your Princess Leia earbuds on. Love it. Thank you so much for your dedication, and all of you. You've been amazing. And I think that's probably it. We'll share all the info, and we'll see you next week for heat bumps. Thanks everyone for watching. See you soon. Bye.
Take care all.